Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Triskaidekaphobia, which is the fear of the number 13 by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. And we have, within a cage, digits must not repeat, and they sum to 13. So, for example, we could have something like, say, 3, 4, and 6 here. And that would be valid because 3, 4, and 6 add up to 13, and there are no repeats in this cage. What we cannot have, for example, is something like 3, 7, 3, because these digits repeat in the cage, and that's not allowed. Even though they add up to 13, that doesn't matter because there is a repeat within the cage. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, the one that comes to me, well, there's a couple of things here that are interesting. We have here, these digits add up to 39, and we know these digits add up to 45. Well, that means this digit must be 6 greater than this digit here, right? Because if you subtract out this digit and add that digit, that gives you 45. 45 minus 39 is 6, so these digits are going to be all the same. So that means this digit minus that digit must be equal to 45 minus 39, which is 6. And it's the same thing here. So this has to be 1, 2, or 3 here. And this must be 7, 8, 9 to be 6 greater than that. We have also 1, 2, 3 there, and that's 7, 8, or 9. But in box 4 and box 6, we have a 4-cell region, which adds up to 13. What are the possible combinations? We have 1, 2, 3, 7, 1, 2, 4, 6, and 1, 3, 4, 5. There has to be a 1 in each of these boxes, which means this can never be 1. This can never be 1. Where is the 1 in row 6? It cannot be anywhere but, and so this has to be 2 or 3, and this must be 6 greater than it, so this is 8 or 9. This is 2 or 3, which makes this 6 greater than it, so it's 8 or 9. Where's the 1 in row 6? Cannot be here, cannot be here, because they have to have a 1 in the 13 box here. So it can't be here, because these add up to 13, and 1 plus another digit is never adding up to 13, so 1 has to be there. We have something similar in box 1 and box 3. One of these digits has to have a 1 in it. One of these digits has to have a 1 in it, which eliminates 1 in the rest of those boxes. Well, where is the 1 then in row 3? It has to be along here. So one of these is a 1, and it can be 1 plus the other 2 digits adding up to 13 minus 1, which is 12. So we could have 1, 3, 9, 1, 4, 8, or 1, 5, 7 here. We just can't have a 1 there. And we know these digits must be 4, 9, 5, 8, or 6, 7. To add up to 13. Same with this. The 2 or 3. So this has to then be 1. It cannot be 2, 3, 7. It's either 2, 4, 6 or 3, 4, and 5. So we're guaranteed 1 and 4 are here. Same with this. This is 1, 2, 6 1, 2, 4, 6, or 1, 3, 4, 5, with a 4 guaranteed here, which means where is the 4 in row 6? Cannot be here because the 4 has to be in this box. Can't be here because 4 has to be in this box, which means 4 has to be here, which makes this a 4, 9 pair. That leaves the remaining digits in row 6 as 5, 6, 7, 8. These could, though, include 1, 2, 3, 7 here. We cannot have 1, 2, 3, 7 here because that would eliminate all possibilities for that cell. It's the same for that cell there. Okay, so this is a 4, 9 pair, which means this cannot be a 4, 9 pair here. So to add up to 13, we cannot have 1, 5, 7 here because that would eliminate all possibilities for this cage there. So this must be 1, 3, 9 or 1, 4, 8, adding up to 13. That seems okay. This cannot contain 1, 4, or 9. So 3 digits adding up to 13 without 1, 3, and 9. Well, okay, let's do the other one. So this, well, that's not helpful. 1, 4, 9. Okay, so possibilities of 13 cannot be 2, 3, 9. Because if we already have a 9 accounted for in the box. No 4 involved. So 2, 3, 9 doesn't work. 2, 5, 6 does. What about 3? 3, 5, and 6 is going to be too large. And 2 and 3 again requires no wait. It's 2, 3, 8. Okay. So 2, 3, 8 works. 2, 5, 6 works, and those are the only things. So we're guaranteed 2 has to be there. So this is 2, 3, 8 or 2, 5, 6, which means 7 has to be one of these 3. We have guaranteed 2 here, so this can't be 2 here or 2 here. Where are the 7 and 9 in row 5 then? 7 can't be here because of it's 2 can't have 2, 4, 7 available anymore to add up to 13, and we don't have 1 available. And yeah, this is a 1, 2, so that means this cannot contain 8. So therefore the 8 has to be, this has to be a 7, 9 pair here, because those are the only places that can have 7 and 9 remaining in row 5. Whereas the 8 then it has to be here, which means this is a 2, 3, 8 triplet. That eliminates 2, 3, 8 in the rest of the box, so the rest of the box is 5, 6, and 7. That eliminates 5, 6, and 7 in the rest of the row. Which leaves an 8, 9 pair remaining in row 4. We are guaranteed a 9 here and a 9 here. No more 3s here. We know this is 5 or if this is 5, 8, this has to be 6 or 7. Or if this is 6, 7, that forces this to be 5. So we have a guaranteed 5 either here or here, which eliminates 5 on the rest of the column. 5. But that doesn't really tell us too much. 9 can't be here. 9 cannot be here. 9 can't be here, and 9 cannot be here. So where is 9 in box 1 and 3? They have to be in this one of these 3 cells. And in box 3, they have to be in one of these 3 cells. Which means where is the 9 possible in row 2? They have to be here. That eliminates 9 from the rest of the box, so this cannot be 1, 3, 9. It's 1, 4, 8. That eliminates 1, 4, 8 in the rest of the box, so this is not 5, 8. It's 6, 7 as a pair. 6, 7 eliminates 6, 7 in the rest of the row. So no 6, 7 here. It's 5. No 5 here. No 5 here. Remaining digits of box 2 are 2, 3, 5, and 9. No 9s here. Remaining digits of column 5. 1, 2, 3, 4, 8, and 9. Remaining digits of row 3. We have 2, 3, 5, 6, 7, 9. Where is 8 in box 1 and 3? They cannot be in the 13 cage here. They can't be in the 13 cage here because 1, 2, 3, 8 at minimum adds up to 14. So it can never be in a 4-cell 13 cage. So 8 has to be one of these 2 digits here and one of these 2 digits here in boxes 1 and 3. Well, we know one of these 2 has to be 8. So in row 2, 8 has to be one of these 2 cells. In row 4, 8 has to be one of these 2 cells, which eliminates 8 in the rest of columns 1 and 9. This can't be 9 because of 9 guaranteed in this column. So this cannot contain 8 or 9 here. We have 1 through 7. This can't contain 8 or 9 here. Oh, that's interesting. So these 3 digits cannot have an 8 or 9. So at minimum, so this can be 1, 5, 7. 2, 5, 6. That's not. Yeah, 3, 4, and 6. 1, 5, 7, 2, 4, 7. Or 3, 5, 6. Three, 4, 6, not 3, 5, 6. Okay. One, 5, 7, 2, 4, 7, 3, 4, and 6. So those are all possibilities. Oh, so this cannot be 8, and this cannot be 8, because we have a guaranteed 8 here and here and here and here. Mm. Ah, so we have to have a 9 be here or here, and a 9 be here or here, which means this, can this be non-8 or 9? If this were not 8 or 9, 8 would have to be here, which means 8 couldn't be there, so 8 would have to be there, and 9 would have to be here, which means 9 couldn't be here, so 9 would also have to be there, and we have a contradiction. So this has to be 8 or 9 here, which eliminates 8 and 9 in the rest of the column. So this cannot contain 8 or 9 here. That's interesting. I think this is also 8 or 9 for the same reasoning, right? If this is not 8 or 9, 8 is here. No 8 there, so 8 has to be there. 9 has to be one of these two because this is not 9, which means 9 can't be here, which means 9 has to be there. So this is 8, 9 as a pair here. That eliminates 8 and 9 in the rest of the column here. Well, to add up to 13 with only a 2 or a 3 and no 8 or 9, that's not 157. So you would have to have 2, 4, 7 here as a possibility. 2, 4, 7 or 3, 4, 6. So we're guaranteed 4 has to be one of those two digits then, if that's the case. We don't have anything here as instructive because we don't have an 8, 9 pair here in this column. So 4 eliminates 4 in the rest of the box and column. So there's no 4 here, which means 4 has to be one of these two digits, which means 4 in column 1 has to be one of those two digits here. We have 1 through 7 here, no 4 here, no 4 here, no 4 here. This is also 1 through 7. With no 8, yeah, 2, 3, 8, 2, 2, and 3 together require 8 to add up to 13. 2, 4, 7 works, 2, 5, 6 works. Oh, that doesn't have to have a 4. Yeesh. Okay, well. 2, 4, 7, 2, 5, 6, or 3, 4, 6 here. We have 1 through 7 here, 1 through 7 here. We know these are different 8, 9 pairs. So any cell that sees both of these cells cannot be 8 or 9. So we cannot have 8 or 9 here. So the other 8 or 9 has to be one of these two digits. Interesting. So whichever digit is that, these can't be either. So this is 1 through 7. This digit cannot be the same as that, so it's pink, which means it can't be the same as that. So that's blue. So this can't be blue, this can't be blue, this can't be blue, and this can't be blue because these are different values. So this has to be blue there, which means this is the other 8 or 9, which eliminates 8 and 9 in the rest of the column. So this cannot be 9, which means blue has to be 9. Interesting. So this is 9 and pink is 8. There's no more 8 here. Where's the 8 in row 2? It has to be there. 8 eliminates 8 here, so it's 9 and 7. That means this can't be 9, it's 8. This can't be 7, it's 9. So there's no 8 here, no 7 here. This is 5, 6 as a pair. That's not going to work. We don't have 8 available here. What the... My logic wrong? I don't think so. 45 minus 8 gives us 37. Then plus 2 gives us 39. Yeah. So these are different because, so therefore, since these are different, these have to be different also for that to add up correctly. So we have a guaranteed 8 here or here, and then 8 here or here. We have a guaranteed 9. Something's wrong with my logic. Hate this. Hate it when I don't know where I messed up. Okay. So 39 is the sum. 45. 45 minus 7 is 38. Plus 1 would give us 39. Yeah, 1, 2, 3, 7, 8, 9. 1, 2, 3, 7, 8, 9. 1, 2, 3, 7. 1, 2, 4, 6. Add up to 13. Yeah, you can't have a non-1 because that would be 2, 3, 4, 5. So we have to have 1 be here, 1 be here. That eliminates 1 here and 1 here. So where's 1 in row 6? It has to be there. We cannot have 1, 2, 3, 7 because this is 2 or 3. So it's only 1, 2, 4, 6 or 1, 3, 4, 5. Either way, we're guaranteed a 1 and a 4 here, which eliminates 1 and 4 in the rest of... So this is 1 through 6, 1 through 6. Where's 4 in row 6? It must be 4 and 9 here. This cannot be 4. We have the similar situation here. We have a guaranteed 1 there, a guaranteed 1 here. Where's the 1 in row 3? 1 has to be one of these. So it must be 139, 148, or 157, with no 1 being there. Again, 13 without 1, 4, or 9. So 2, 3, 8. No 2, 4. 2, 5, 6. So this is 7, 5, 6, or 7, 3, 8 here. This already adds up to 26 plus 1, 27, so the rest are 18, which satisfies 3, yeah. So 2 is guaranteed here. That eliminates 2 in the rest of the row. Where are 7 and 9? This must be 7, 9 as a pair. This has to be 5, 6, 7, 8. And 5, 6, 7, 8. This digit is not the same as that digit, and this digit is 6 greater than that. Same with that digit being 6 greater than that. This cannot be 4, 9, so we have 5, 8, or 6, 7. Again, if we had 5, 7 here, that would eliminate all possibilities for this cage here, because it cannot be 4, 9, because that would eliminate all cells in this cage here. So it's 1, 3, 9, 1, 4, 8. One of these is guaranteed to be 9. We have a 7, 9 pair here, which means we don't have 7 or 9 available in the rest of the row. Whereas 8, it has to be here, so this is 2, 3, 8. That eliminates 3 and 8 in the rest of this row here. We cannot have 5 and 6. Oh, well, this is 5, 6, 7, which eliminates 5 and 6 in the rest of this row, so that makes this 8, 9. So we're guaranteed a 9 there, we're guaranteed a 9 there. 9 cannot be here or here in columns 1 or 9, because we're guaranteed a 9 there. This can't be 1 through 9. So, where... Oh, we could have an 8 here. Well, no, we can't. 9 can't be here, 9 can't be here, so in row 2, 9 has to be one of these two. Which means this cannot be 1, 3, 9, it's 1, 4, 8, adding up to 13. Which eliminates 8 in the rest of the box. So this can't be 5, 8, it's 6, 7. That leaves this as 2, 3, 5, and 9. With no 9 being there. 8 again has to be one of these two. Cannot be here. So 8 has to be here or here, or 8 is here or here. In row 2, 8 has to be one of these two digits. In row 4, 8 has to be one of these two digits. 9 has to be one of these digits. That means 9 can't be here, so we have to have 9 here, or 9 here, and 9 here, or 9 here. These are 1 through 7. We have a 1, 2, 3, 4, 5, 6, 7 quadruplet, or sextuplet in row 1, which forces this to be an 8, 9 pair here. That eliminates 8 and 9 in the rest of column 3, so there's no 9 here. Oh, maybe I messed this up. Well, I don't even know. Remaining digits of row 3 are 2, 3, 5, 6, 7, 9. No 9 here, no 9 there, and no 9 here. Again, to add up to 13. So this is different than this, because these two digits must be 6 greater than these, and these have to be a 2, 3 pair, which are different digits. That means this can't be blue, it's pink, which means it can't be pink, it's blue. Blue cannot be here. Blue technically could be any of these 3. But 8 can't be here, and 9 can't be here. Because, again, in row 2, we have an 8 guaranteed in one of these cells. In row 4, we have an 8 guaranteed in one of these two cells. So 8 can no longer be here. But... So that means this is an 8, 9 pair. That eliminates 8. Oh, I forgot about the 9 there. Okay, that's why. That's where I messed up. So where is 8 in... 8 cannot be here because of 8 in the... What has to be one of these two cells. Neither can that. So where's 8 in row 6? It has to be here. 8 eliminates 8 here, so it's 9 and 7. 9 eliminates 9 here. So the reason why is I messed this part up. 9 can also be here. That's the reasoning for that. Anyways, 9 eliminates 9 here, so that's 8. 7 eliminates 7 here, so it's 9. There's no more 8 here. Where is the 8 in this box? It must be here. So the blue cells are 8. And the pink cells are 9. There we go. That eliminates 9 here. Where's the 9 in row 3? It has to be there. Ugh, I messed that up so badly. Anyways, I don't know how I removed that 9 there. That was really bad. 9 cannot be here, cannot be here, cannot be here. So 9 is one of these two digits, which means either this is 1, 3 as a pair, or this is 1, 3 as a pair. We're not sure which. Either way, this can't be 1 or 3. We knew that already. It's either 4, 7, 5, 6, or 4, 6. We don't know which. Oh, this is 8, so this must be 6 smaller than it. So this must be 2, which means this can't be 2. That's 3, 3, 8, and 2 add up to 13. This has to be 4, 7, or 5, 6. 1, 2 eliminates 1, 2, 4, 6 as a possibility here. So this is 1, 3, 4, 5. That eliminates 1, 3, 4, 5 in the rest of the box. No 5 or 7 there. It's 6. That means this can't be 6 here. It's 1, 5, or 7. That eliminates 3 and 5 in this box. This is 1, 2, 4, 6. No 3 here because of 3 in the row. 2 eliminates 2 here. Where is 2 in box 6? It has to be here. No more 5 here. So no more 2s here or here available. One of these is 9 with 1, 3. We're not sure which. 6 and 7 eliminate 6 and 7 in the rest of the column. This has to be 8 here. That's the only place for it in that box. So that leaves us with 1, 2, 3, 4, 5 remaining in column 1. No 2 here because of 2 in the row. 6, 7 eliminates 6, 7 here, so it's 5. No more 5s here. 6, 7 as a pair. This is again 1, 2, 3, 4, and 8 and 9. No 8 here, no 8 here, no 9 there. 8 is one of these 3 digits. We cannot have 8 or 9 here, or 2. So the possibilities without 8 or 9, again, you have 7 with 1, 5. 7 with 2, 4, but 2 is not available. So 7, 1, 5 would eliminate all possibilities for that cell there. So this cannot be 7, 1, 5. It can't be 2, 2, 4, and 7 because of the 2 in the box. So this has to be 3, 4, and 6, adding up to 13. That eliminates 3, 4, and 6 in the rest of the column. This can't be 1, so this has to be 2, 5, or 7, which means 1 in column 9 has to be there. That eliminates 1 in the rest of the box and row. So 1 has to be there. Where is 1 in column 1? It must be one of these 3 digits. We already knew that, though. 3, 4, and 6 eliminate 3, 4, and 6 to the rest of the box. That's just 1, 5, 7. 3 eliminates 3 in the rest of this column. 2. We don't have 1, 2, 3, and 7 anymore in this box. Why? Oh, 2 cannot be here or here. So this has to be 1, 3, 4, 5, adding up to 13. It eliminates 1, 3, 4, 5 in the rest of the box. This is 2, 7. This can't be 1, 3, 5, or 7, so that's 6. That eliminates 6 in the rest of the row. So this must have 1 and 6 to add up to 13, which leaves us with 2 and 4 left. So no 3 and 5 here. No 7. This is 1, 2, 4, 6, adding up to 13. That means there's no 2 here. It's 3, 5, 7. That eliminates 3, 5, 7 here, so that's 2, which eliminates 2 there, so it's 7, which eliminates 7 here, so it's 5 and 7 there. 7 eliminates 7 here. 6 can't be here because of 6 in the column, so 6 has to be there. Hmm. 7 eliminates 7 here, so it's 6 and 7. That eliminates 6 in the rest of this row. We have a 1, 2, 4 triplet in box 1, which eliminates 1, 2, 4 in the rest of the box, so no 2 or 4 there. It's 6. That means 6 cannot be here. Five has to be one of those two digits. So we have 139 as one of these digits here because we have a guaranteed 9 in a 3-cell cage that adds up to 13. So it must be with 1 and 3. The other cage has to have 2 with it, without an 8. So no 2 and 2 without 3 either. So it would have to be 2, 4, 7 or 2, 5, 6. And 6 cannot be here. Where is 6 in box 7? It has to be here. So this must be 2, 5, 6 there. That eliminates 2, 5, 6 in the rest of the column. So no 5 here, no 5 here, no 2 here. We have a 1, 4 pair in column 3, which eliminates 1, 4 in the rest of the column. So no 1, 4 there, it's 3. No 3 there, it's 7. No 7 there. No 3 here, so this is a 1, 4 pair here, which eliminates 1, 4 in the rest of the box, so this can't be 1 or 4. It's 5. 5 eliminates 5 here, so it's 3 and 5. Which means 3 can't be here. This can't be 5 either. And 3 can't be here. 1 can't be here. So 1 and 3 both have to be here, which forces this to be 9. No 1 or 3 there. It's 4. That means this can't be 4. It's 2. No more 2 here. It's 3, 5 as a pair. 3, 5 eliminates 3, 5 of the rest of the row. So no 3, 5 there. It's 4, which eliminates 4 there. So it's 5 and 3. No 3, 5 here. No 2 here. This can't be 9 anymore. This can't be 2 or 4. So this must be 7, which makes that 2. 2 is eliminated from these cells here. 9 cannot be here because of 9 in the row. We have a guaranteed 1 in rows 8 and 9 in box 7, and a guaranteed 1 in rows 8 and 9 in box 9. That eliminates a 1 in the rest of those boxes. So 1 has to be one of these two digits. 4 eliminates 4 here. That also eliminates 4 there. 4 eliminates 4 here, so that's 1 and 4. 1 eliminates 1 here, so it's 4 and 1. 4 eliminates 4 here, so that's 1 and 4. 9 has to be one of these 3 digits. Okay, remaining digits of row 9, we have 1 through 7. No 1 here because of 1 in the column. You could have 2, 3, and 8 there. 1 cannot be on... Right. So, the 3 digits in box 8 that are not in cages must add up to 45, minus 13, and minus another 13, which is 26, which adds up to 19. So 1 cannot be in one of those digits, because if 1 were in one of those digits, 1 plus 8 and 9 at most adds up to 18, which is too small. So we have to have 1 here, And these two must add up to 12, which is 13 minus 1. Well, this can't be 3 and 9 because of the 9 in the row. And the only digits left now are 4 and 8, which must add up with 4 and 8 to add up to 13. That eliminates 4 and 8 in the rest of the box. This has to be 9. And it adds up with 2 other digits to add up to 19. And 2 can't be here, because we can't have 8. We can't have 4 and 6. We can't have 1 and 9 anymore, so this must be 9, 3, and 7, adding up to 19. That leaves this not as 3, so this must be 2. 2 eliminates 2 in the rest of the column. 1 eliminates 1 in the rest of the column. We have a 4, 8 pair remaining in column 5. That eliminates 4 and 8 in the rest of the column, so no 8 here, it's 3, no 4 here, it's 9, which makes this 4. 2, no 3, and 7, so this becomes a 5, 6 pair. 5 and 6 eliminate 5 and 6 in the rest of the column, so no 6 there, it's 7 and 6. And the 5 can't be there, so this is 3 and 5. No more 3 here, no 3 here. No 3 or 7 here, so that's 9. Therefore, this can't be 9 there. 9 eliminates 9 here, so it's 2 and 9. That eliminates 2 here, so it's 8 and 2. 8 eliminates 8 here, so it's 4 and 8, which leaves this as 1. 7 eliminates 7 here, so it's 3 and 7. 3 eliminates 3 here, so it's 6. No more 6 here. 6 eliminates 6 here, so it's 5 and 6. 6 eliminates 6 here, so it's 5 and 6. 8 eliminates 8 here, so it's 4 and 8. 4 eliminates 4 here, so it's 3 and 4. 3 eliminates 3 here, so it's 1 and 3. 1 and 5 eliminate 1 and 5 here, so it's 7, which makes this 1, which makes this a 5. Ugh. That was a pretty bad mess up there. I don't even know how I removed that 9. That was pretty bad. Yeah, this logic actually made a lot of sense. So it was correct. I just messed this part up. So then I was like, wait, we don't have 8 or 9 here. We have to have both 8 and 9 here, specifically, actually. But it wasn't the case. Anyways, I hope you enjoyed this solve, despite my mistake, and I'll see you next time on Frank Puzzles. Take care.